Now we come to our final video of the day. We are almost there, you'd be pleased to know, and it's finishing with yours truly. I'm going to be looking at dynamic arrays with repeatable calculations in here. It's a longer one, so I'm probably going to be answering the Q&A in the chat, but to wrap up with here, because we may not have time to just go through it all afterwards. What I'm just going to put in here, I'm just trying to get the sharing up and running. Ready? We are going to be looking at repeatable calculations. So it's more lets and lambdas like Talia. Talia did actually help with this, but I'm hoping that you'll find it interesting. And it does actually do a refresher on 12 very useful functions as well. So even if you're not quite sure about the last bit, it's probably worth it just from the bit before. So over to an older photo of myself here. I'm trying to get back to that fighting weight at the moment. Liam, take it away.
Hello, my name's Liam BASTICK. I'm a director with some product and a 13 times Excel MVP, and I'd like to welcome you formally to Excel Virtually Global 2023. My topic is going to be on financial modeling with dynamic arrays, and in particular, repeatable calculations. So for this particular topic, we really need to understand two key things: dynamic arrays and several key functions. And by several, I mean 12. And if you don't know what 12 is, well, it doesn't matter. Get it? Oh, the jokes are only going to get better. Not. So dynamic arrays available in Excel 365. This is what is referred to when any formula has the potential to return multiple results into a range that can be extended both in rows and columns. So if you look at the left-hand graphic here, I've got my original data with a table of information about shapes, colors, and sides. And then what I've done in the right-hand graphic is I've put a formula into cell F33, which simply says equals F12 to H27. And it's gone into the cell that's been shaded. That's got the light blue shading with the red font, and it's just equals F12 to H27, and it's spilled. That blue border is not something I've put on. That's Excel extending the range by 3 columns, so columns F, G, and H, and it's also going down 16 rows, so from row 33 to 48. It's spilled it, and that's what we refer to as a dynamic array, and that's what we're going to play with. Now, before I present the problem and what I'm going to show you here, let's go through those 12 functions. The first one I want to talk about is choose. Now, this function uses an argument, index number, to return a value from a list of value arguments. And the choose function employs the following syntax to operate. We've got choose, and then in brackets, index number, comma, value 1, and then carrying on after that, value 2, etc., etc., etc. Now, the choose function, as I said, has the following arguments. The index number is required and is used to specify which value argument is to be selected. And it must be a number between 1 and 254, or a formula or reference to a cell containing a number between 1 and 254. Now, if index number is 1, choose will return value 1. If it's 2, it will return the second value. And if it's less than 1 or greater than the number of the last value in the list, choose returns the hash value error. So it just keeps going on and on and on. Now, if index number is a fraction, it's truncated to the lowest integer before being used. So you've got a value 1, value 2, etc. So if you did 1.3, then value 1 would be used, and so on. Now, value 1 is required, but subsequent values are optional, and they may be between 1 and 254 value arguments from which choose selects a value or an action to perform based on index number. And the arguments can be numbers, cell references, defined names, formulae, functions, or text. Let's take a look at an example. If you have what I call contiguous data, and by contiguous I mean something you can just highlight with a mouse without holding the control button down like this, that's non-contiguous, that's contiguous. Then if you want to make a selection from there, I wouldn't actually use choose, I'd use index, because index just says take index, find a list, I've got here A, B, C, D, and then pick the second item from it. Close brackets, bang, B. Change this to number 4, and it picks D, and so on. That's the easiest thing to use when everything is working fine. Now, when it's all scattered like this, and it can be on other sheets, or you could have written formulas or whatever, index isn't going to work. And this is where choose comes in. So what we would do here is go equal choose, And the first argument is the index number. So that's going to be the choice here, C36, and then you pick the selections. So input 1 is going to be C31, then input 2 is G32, 3 is C33, and finally input 4 is G34. This is non-contiguous, and then this will pick B, and if I pick option 3, it picks C, and so on. And these don't have to be cell references, they could be links to other workbooks, they could be formulas, and so on, and so on, and so on. But choose is the first of the functions that we need to consider, but there are more. Our second function in the dirty dozen, shall we say, of 12 functions that we require may not be so well known. It's one of the dynamic array functions. The drop function excludes a specified number of contiguous rows or columns from either the start or the end of an array, and it has the following syntax: drop, and then in brackets, array, comma rows, comma columns, close brackets, with columns in square brackets according to the Microsoft syntax, but more on that in a minute because it sort of is a bit interchangeable between the rows and the columns. Now, as I say, the drop function has the following arguments. Let's go through them. Array. This is required and represents the selected array from which to drop the rows or columns. Rows, Microsoft says is required, but as long as you've got one of rows or columns, it's okay, and denotes the number of rows to drop or exclude from the top. Now, if that number is negative, the value is dropped from the bottom of the array. Columns, on the other hand, is optional if there's a rows and vice versa, and denotes the number of columns to drop or exclude. If this number is negative, the value is dropped from the end of the array. Now, it should be noted that when rows or columns are not provided or missing, all rows and columns will be returned. And if the absolute value of rows or columns is greater than the number of rows or columns in the array, then all rows or columns are supposed to be returned. But when I do it, I get hash value appearing everywhere. Excel will return another error message, #calc, to indicate an empty array when rows or columns is 0, and it will return #num when the array is too large. Let's take a look at some examples. Drop is very simple when you figure it out. Here I've got some inputs. I'm going from alpha to, collapse. So I'll let you go through that. That's my phony phonetic alphabet. So let's try with drop, which is a dynamic array function. So if I put drop in here, it wants the array. So I'm going to pick up cells B2 to F6. And then I'm just going to go comma 1 to show I don't need to put the columns in as well. If I do that and go close brackets, this is what happens. Bang. It's actually gone through, if you see here, and it's dropped the first row. Alpha, Bravo, Charlie, Delta, Echo have gone. That's what it's actually doing here. And if I go back into it instead and put -1 instead, what happens now is I get the first 4 rows and it's missing the last one. Similarly, I can go back in here and say, okay, I'm going to go drop B2 to F6 and I'll go instead, comma, comma, and we'll go 1 this way. And what that will do now is it will drop off the first column and we'll have Bravo, Golf, Liam, Quebec, and Victor going down here instead. And we can even get more complex should we wish and do things like 2, 3. So what's happening in this particular case is it's dropping off the first 2 rows and the first 3 columns. So what we end up with is November, Oscar, Sierra, Tango, and Whiskey collapse. Well, we would, wouldn't we? Next up is another dynamic array function. This is the Hstack function, which returns the array formed by appending each of the array arguments in a column-wise fashion. That's Microsoft's jargon, not mine. I'll be honest, I get confused because I always get Hstack and VStack mixed up because I think they should be the other way around when I consider VLOOKUP and HLOOKUP. Anyway, it's got the following syntax. It has Hstack and then array 1 and then optionally array 2, array 3, etc. So of these arguments, the array, the first argument is required, the others are optional, and represents the arrays to be joined together or appended. Now it should be noted that Hstack returns the array formed by appending each of the array arguments in what Microsoft referred to, as I said, as a column-wise fashion. And the resulting array will be the following dimensions. The number of columns will be the maximum of the column count for each of the array arguments, and the number of rows will be the combined count of all the rows from each of the array arguments. Now, Excel will return an #NA error if an error has fewer rows or columns than the maximum in any selected array. So to remove the errors, you should use the if error function if needed. Let's take a look. Here I have two arrays. In cells B2 to D3 with a blank cell, I've got Mary had a little lamb. And similarly in cells F2 to H3, I've got her father shot the shepherd. And Hstack is very simple. You just go equals Hstack, open brackets, and you say, right, I want to combine or append this with this. And then I go close brackets, press enter, and it has stacked them. I always think this is vertically next to each other, but this is column-wise is what they're saying here. Now, I can change this if you're feeling a bit upset here. Let's get rid of this again. Let's put something a bit more pleasant here, shall we? How about this? Looks much more palatable. If I can spell. And if I do this here, equals Hstack. And then I'm going to go here, this one, comma this. Very simple. That's all there is to Hstack. Now I'm going to guess there aren't many people who don't know this function. It's the standard logical test. If has the following syntax: if open brackets, the logical test, so to determine whether something's true or false, then what to do if it's true, value if true, and then what to do if it's false, going through there. And it has these three arguments. Logical test is the decider. That is a test that results in a value of either true or false. Now, strictly speaking, that logical test decides whether something is true, and if not, it's deemed false. Value if true is what to do if the logical test is true, whereas value if false is what to do if the logical test is false, and strictly speaking, we mean not true. If this argument is left blank, this argument will have a default value of false. Now, why I say that is if we are testing to see if something says the word boy in there and it says 7, then it will actually be not a boy and do the value if false. See what I mean? Let's go and take a look at an example anyway. Here I have two numbers and I've given them a range name. 3 and 4 here are numerator. You can see here numerator in the actual name box, and denominator. And if I wanted to see what the fraction is, I could simply do equals C2, which is named numerator, divided by C3, which is denominator, and we get 0.75. Easy. But what happens if this is 0? Or if it's blank? It causes the dreaded #0 error. And this is where if comes in for all these sorts of ratio calculations. You can put things in here saying like if open brackets denominator equals 0, then some sort of error trap. So we might say NA or something like that. Otherwise, do the calculation. And that's all there is to it. NA. But remember, it's only testing for what you have actually tested. So if I put Liam in here, it would still go wrong because it's not equal to 0, so it won't give NA, and therefore decides that it's going to try and do numerator divided by Liam. It's not as clever as you might think. And similarly, if I put 4 in here and I put dog there, we get hash value again because we know that's wrong because dog divided by 4 should be kebab. Next up is the int function, that good old-fashioned Yorkshire function, isn't it? Well, sort of. The int or int function rounds a number down to the nearest integer. As you can see on the number line, if it's between two values, it looks to the left. Therefore, int of 0.8 will be 0, int of 2.7 will be 2, and int of minus 2.6 will be minus 3. And that number line, I think, helps to explain it. Now it employs the following syntax to operate. It's just int of a number, and that number is required and represents the real number you wish to round down to as an integer. Let's take a look. As I say, there's not much to say about the int function. You just do equals int and then you reference the number. It's as simple as that. And then it rounds it down to the nearest whole number, which is 7. And I say rounds down to that whole number, so it doesn't have to be the nearest, but it's the next one down is what I mean. If I put minus 5.8 in there, many people think this should be minus 5, but of course it will be minus 6 because of how the number line goes. But that's all there is to it. Next up, we've reached the 6th of our 12 functions, so we're halfway there. Lambda has been released originally into the Office 365 beta world, and it's still coming through into all sorts of versions of Excel, and it apparently completes Excel and provides you with the ability to create your own reusable formulae. It's what has made Microsoft's Excel what we call Turing complete. Lambda allows you to define a custom function in Excel's very own formula language. Moreover, one prescribed function can call another. And if that function calls itself, then that's an example of recursion, which is a way of a function calling itself, called recursion, which is a way of a function calling. Yeah, you know what I mean. Anyway, the syntax is lambda, open brackets, parameter 1, and then you can have parameter 2, parameter 3, etc., and ending up with a calculation, where your parameter 1 and 2, etc., are values that you wish to pass to the function, such as a cell reference, a string, or a number, and calculation is the formula that you want to execute and return as the result of the function. It must be the last argument, and it must return a result, and it's required. Let's take a look. Let's take a simple example. Let's try out the following formula. Equals lambda, and then we'll put in here x, which is my variable, comma, x plus 1. So where we have here x is the argument, which you may pass in when calling the lambda, and therefore x plus 1 is the logical operation, the calculation to be performed. For example, if I were to call this lambda function and define x is equal to 5, then Excel should calculate 5 plus 1 is 6. So if I just press enter here, what happens? Oh, I get hash calc. That's because it's not quite as simple as that. You need to name your lambda. So in order to name your lambda, we've actually got to have it so that we can reuse it. We need to use the name manager, which is on the formulas tab, and we've got in here name manager. So if we click on that, Control plus F3, and then in here we can click on new, and we can take it in here, not call it formula, we'll call it something like, I don't know, Liam Lambda. And that's going to be a formula that we'll then put in there. We'll make it actual workbook one, and we'll use the formula again, equals lambda, open brackets, x, comma, x plus 1, close brackets, and then we've named it. Great, so you can see it's in there, it's all looking fine. Now we need to call that, so we click close, and in here now I just type equals Liam, and it's there. Liam Lambda's in there, and now what I just do is I put the number 5, and it will add 1 to it. We've made a user-defined function without creating VBA. Now, why did the first one go wrong? Well, if I just put lambda in again, let's go back to what I actually did. You can actually do a workaround here of doing x and x plus 1. Why it gave the hash calc error is we hadn't defined a variable for it. So if I put in brackets 5 and then do it, you'll see it actually gives 6. Now, this trick doesn't always work though, so just be careful with this. This is just explaining why it didn't work in this particular situation, but it's often better that you name it or you have the lambda in a dynamic array formula, which we're going to do in a few minutes. But we've still got half the functions to go. Let's continue. Lambda's sister function is let, which was introduced into Excel back in March 2020. At the time, though, only to the Insiders channel, and this allowed you to stop writing the same expressions time and time again in a formula and allowed portability of segments of a computation for different formulae. As Microsoft put it, it's names on a formula level. Now, in essence, this function assigns values or expressions to define names and then passes these to calculation results. It can store intermediate calculations, values, or defining names inside a formula. The defined names only apply within the scope of the let function, though, in a similar way to variables in general programming scenarios. And so what I will often do with these sorts of range names is I'll make them lowercase, so they have no capital letter at the beginning, just to sort of highlight the difference. Now, if you reuse the same expression multiple times in a formula, Excel calculates that expression multiple times. That's not a good thing. Let allows you to name the expression and refer to it using that name, similar to the var or var function in a DAX expression in Power Pivot for those that know the language. Now, any named expression is calculated only once, even though it may be referred to many times in the formula, and this can significantly improve performance and it can speed up your spreadsheets. Now, to use the let function, you must define pairs of names and associated values, and then a calculation that uses them all as the final argument. And at least one name or value pair must be defined. It has the following syntax to operate. Let, open bracket, name 1, comma, value 1, and then you could have more pairs of names and values, so on, and ends in calculation. So The syntax is name1 is the name for the first value, value1 is the value to associate with the first name, and then name2 and value2 are the additional names or values for the second and subsequent names and values. And calculation at the end is the calculation to perform. It's got to be the final argument, and it can refer to any of the defined names in the let function. Now, the main benefits of using let are readability and performance. Readability will let function tracks the changes in defined cells or expression in a dynamic way, so there's no need to remember what a specific range or cell reference referred to. So with the ability to define variables, it can provide more meaningful context to end users. And with performance, well, let allows named expression in the formula and calculations only the once, even if it's referred to many times in the formula. And again, this significantly improves the performance of complex expressions. Let's go and take a look at an example. I'm going to start with something simple. Here, I have put in Alfie and Betty, and I'm just going to click into this cell here and type in Alfie. So this is given a name range, and this is going to be Betty. And notice I put a capital letter at the beginning. So Alfie, Betty, and I can go here equals, click on this cell, plus that one. Amazing. Wow. Liam, what's that got to do with the let function? Well, nothing at all. But down here, I'm going to have Charlie and Delta, and this time I'm not going to name them. So they're just C21 and C22. Now I know I can just add them together, but I'm going to use the let function. So I'm going to go equals let, open brackets, and the first thing I'm going to do is have Charlie with a lowercase c to highlight that this is a name only recognized within this let function. So Charlie, and I'm going to give that the value of C21, and then I'm going to say Delta will have a value of C22, and then what I'm going to do is CH8, and you see autocomplete is still recognizing these names that only are contained in this actual let function. So if I do that and then type in DEL, there's Delta, not the Delta, oops, of the function, but Delta lowercase, another good reason why I should do it as a lowercase, and go close brackets, and 5 plus 6 is indeed 11. And that's what let does. It simplifies repetitive things. It simplifies repetitive things. Liam, you've done that before. Now, this dynamic array function is going to go down in the annals of Excel folklore, as it's actually Excel's 500th function. Yay! So you should be aware that the map function has got nothing to do with looking at the US, Russia, or whatever. Instead, it returns an array formed by mapping each value in the array to a new value and applying a lambda, which we've just gone through, to create a new value accordingly. And it has the following syntax. It's map, and then we've got in here array1, comma, and then lambda or array 2, and then lambda or array 3 if we haven't had a lambda in the first one, and so on and so on. So array 1 is a required argument and represents the first array to be mapped. The array 2 and subsequent arrays are optional arguments and represent additional arrays to be mapped. And lambda is a required argument which represents a lambda which must be the final argument and must have a parameter for each array passed or another array to be mapped. That might sound confusing, so let's go and take a look at an example. In essence, all map does is transform values. Let's take an example here of average temperatures. Here I've got the degrees in Celsius, and so we've got here a formula which I've already put in for the point of brevity. Now this table here is called temps. Notice it's just this part that's called temps. So this is the temperatures, and I've got a calculation in here which doesn't really matter what it's doing. It's a big long complex dynamic array formula, and it's looking through and saying, okay, I want the year-on-year comparisons for each month where the average temperature is above 15 degrees Celsius, avoiding a helper column. Blah 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 blah. Doesn't actually matter. That's what I've actually created. Now, the problem is here for the American viewers is these temperatures have been provided in Celsius, which might as well be gobbledygook. So people may not understand it. Now, if a US reader sees a temperature of 25 degrees, they're going to be breaking out for the gloves, bobble hat and duffel coat, whereas us Aussies will be heading for the beach. So we need to convert or transform this data into Fahrenheit so that our US colleagues may better understand. And we can do this with the map function, which is what I've got down here. So I've got this here, and what I've done is I've put this in, and I'm going to just extend this calculation. So it's still got that thing from up there, but then what it's done is it's wrapped it in a map. And then we've said lambda, and we'll create a variable temperature, which is just for this formula, which is why it's lowercase t. You won't see it in the actual name box. And we're saying, okay, if it's a number, we're going to convert that temperature from Celsius to Fahrenheit, which is what conversion does. Otherwise, we'll just leave it as temperature just in there. So it's just got whatever the word is. And that's what it's going to do. It's going to take the numbers in the previous calculation and put them down here. It's not referring to B17 onwards. It's actually going back to the temps table and doing it all in one go. But you can see what it's done is it's converted it. So press enter, it's converted it. And if I actually delete this one here, it still works because it's not referring to that, which you might do with a convert function in Excel. And that's all map does, is it transforms data. Next. We're at the 3/4 mark for the functions now, and number 9 is the mod function, and mod open brackets number comma divisor returns the remainder after the number, that is the first argument, is divided by the divisor, the second argument, and the result has the same sign as the divisor. Now it's particularly useful for generating repeating sequences, as I will show now. Here in row 2 I have got the numbers 1 to 10, and in this cell, I'm going to use the mod function. So mod, open brackets, I want the number. Well, rather than take 1, I'm going to take all these to turn it into a dynamic array formula, so it will spill or propagate, comma, the divisor, let's say, is 4, close brackets. And that gives me the repeating sequence 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, etc., etc., etc. If you're not sure where those numbers are coming from, well, 1 divided by 4 is 0 remainder 1, 2 divided by 4 is 0 remainder 2, 3 divided by 4 is 0 remainder 3, and 4 divided by 4 is 1 remainder 0, and so on. Now, you might want 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, etc. To do that, what you do is you subtract 1 from the number and you add it outside, a little known trick that makes it that more useful repeating sequence, which we will be taking advantage of, especially if we use another function in a minute or two, where I will just give you a quick highlight. If I did 1, 10 here to propagate this, gives me a spill at the moment. Get rid of these, it's just generating the numbers 1 to 10 across. See, so another function coming up in a minute. See, other functions coming up? Let's go take a look. I go on about the offset function all the time. I think a lot of people know it's one of my favorite functions. I'm not going to go through all of its intricacies, but in its most basic form, offset, open brackets, the reference, comma, x, comma, y, will select a reference x rows down, so minus x will be x rows up, and y columns to the right, whereas minus y will be y columns to the left of the reference. Let's take a look. Here I have another array. I've got the numbers 1 to 36 in cells B2 to G7, but I don't reference that whole thing. I will just use offset. So I'll go equals offset and have a starter cell, my reference. Let's go for cell B2. And then going 2 rows down, comma, 3 columns to the right. So 2 rows down will take us from 1 to 7 to 13, and 3 columns to the right will take us from 13 to 14, then from 14 to 15, and finally 15 to 16, which if I press enter is what I get. Similarly, if I say start here as my reference in cell D4 and go comma 1 comma minus 2 just to show what happens with negative numbers, I'm going to be starting off here in cell D4, the value of 15, and the 1 means go 1 row down, so that takes me to 21, and minus 2 will take me 2 columns to the left from 21 to 20, and finally from 20 to 19. And you get that. And that's pretty much for the basic version of offset. That's all there is to it. Our penultimate function in our list should not reduce you to tears. In fact, this reduces an array to an accumulator value by applying a lambda function, which we talked about just a few moments ago, to each value and returning the total value in what is known as the accumulator. And its syntax is as follows. You've got reduce, and then you have initial value, which is optional, comma array, comma lambda. And the arguments are as follows. The initial value, then this is an optional argument and represents the starting value for the accumulator, that is the running total prompted by the lambda expression. Array is a required value and represents the array to be reduced, and lambda is also a required value and represents a lambda function called to reduce the array that consists of two parameters, the accumulator, the returned aggregated value from lambda, and the value from the array. This might be, again, confusing, so I think it's easier to show with an example. Let's go back to our temperatures again. In a table this time, I'm just going to highlight this lot here, and I'm calling this more temps because it's on a different page instead. Now, we could count how many months in this period had an average temperature here between the minimum of 15 degrees and the maximum of 20. And I've given both of these range names min temp and max temp, so with capital letters. And a way to do that is as follows, using this formula, which doesn't look too bad until I expand it. So reduce starts with, well, the initial count is 0, and then it's going to be based on more temps, the table. And then the lambda is going to have an accumulator and a value. So we're going through, and then in order to calculate this, we say, right, if the value is greater than or equal to the min temp and is less than or equal to the max temp, so between 15 and 20 degrees, then we will add 1 to the accumulator, otherwise the accumulator will stay as it is, and that is what comes out. So when you do that, you'll find there are 31 values in there that have a value of a temperature of greater than or equal to 15, but less than or equal to 20. And that's what it's doing. So reduce just takes a big long complicated calculation and reduces it to something that can be quantified and used elsewhere in a model, which is what we're going to do. Hey, we only have one more function to go before we can actually go to what's caused all this, our repeatable calculation. Let's take a look at the final one. It's simple. It's sequence. And so to our final function. This function, sequence, allows you to generate a list of sequential numbers in an array such as 1, 2, 3, 4. It doesn't sound particularly exciting, but it really ramps up when combined with other functions and features. Its syntax is given by sequence, open brackets, rows, and then the optional arguments of columns, start, and step. So let's have a look at the 4 arguments. Rows is required and specifies how many rows the result should spill over. And columns, this argument is optional and specifies how many columns, surprise, surprise, the result should spill over. And if it's omitted, the default value is 1. Start is also optional and specifies what number the sequence should start from. If omitted, the value is determined to be 1. And step, again optional, this specifies the amount each number in the sequence should increase. That's the step. It may be positive, negative, or 0. Now, if it's omitted, the default value is 937,444. Oh no, wait a minute, it's not. It's 1. They're very unimaginative down in Redmond. So, therefore, sequence can be just as simple as using sequence open brackets x close brackets, and that will just generate a list of numbers in a column. Let's take a look. For our final example here, I've just put a value of 5 in here. I'm just going to use that simple form of sequence. So sequence and click on that. And what that will do is it will generate the numbers 1, 2, 3, 4, 5 spilled down a column. And if I change that to 9, it will go 6, 7, 8, 9. But you see the formatting doesn't hold. It's one of the annoying things with dynamic arrays. You've got to actually make sure you put your formatting in the whole time, which is what I've been doing with most of the examples, but just showing it can be a bit of a pain in the proverbial. And see, simple, back to 5. It's a dynamic array formula. Now, if you wanted to go across a row instead, it's very simple. All you do is put a 1 in front of it, so you're specifying 1 row and C2 columns, and then it goes across instead. And that's all there is to it. Now, it seems very uninspiring on its own, but it's very powerful when it's used with other combinations of lets, lambdas, biro, Hstack, VStack, etc., etc. And that's where we're going now. So, as I say, we needed an appreciation of 12 functions and dynamic arrays to come up with our example of creating repeatable calculations simply that will just propagate, they'll spill on their own. And my illustration here is to create just a simple control account when opening a balance, some additions and deductions to get a closing balance, which could be used to feed a P&L, a balance sheet and a cash flow. And I've just done it the once, and I've got an input here maybe where I can change that scenario number to actually show a different one. And I want to write a formula that will just create that calculation however many times I want it. Let's go take a look how to do that. So let's look at an Excel example then of what I'm trying to do. A common requirement in building financial models is what's known as a repeatable calculation, or more accurately, a repeatable block or set of calculations. And this might be to calculate forecast revenue for different products, depreciation for different asset classes, debt repayments for different financial instruments or tranches, and so on. And I thought I would demonstrate a technique for repeating such calculations with dynamic arrays and these functions I've shown you. But brace yourself though, it ain't pretty, but it's pretty effective. Now, in order to illustrate this approach as clear as I can, I'm going to make the repeatable block simple. You can make it more complex, but the idea remains the same. So with this borne in mind, imagine I have this following collection of inputs here. So I've got 10 periods and 10 scenarios, and I can actually change this to 7, and I can change this to 5, and you can see that I've just got this broken down. So I've got a dynamic range here. And for my scenarios 1 to 10, I've got my opening balance, and then the additions I have each period in whatever it is. It could be some sort of sales item or whatever. And I'm going to assume that the actual the amounts that are going to be reduced by will be the previous period's opening balance here. I'm just keeping it simple. So I have a control account going. So for instance, for scenario 1, the numbers here are 489 as the opening balance and 996, 668, 206, etc. And you'll see here, here's my opening balance of 489, there's my 996, 668 and 206. And it's simply opening balance is previous period's closing balance. This is the addition from there, and then the deduction is simply minus the opening balance, and this is the sum. I'm not going to go through the formula here because this isn't what I'm going to calculate, but I've used an offset function so that if I change it to scenario 3, what's happening is it's using this top row to see how many rows down it needs to go to pick up the numbers. So that's what's happening. So nice and easy. What I want to show you are the repeatable calculations on this sheet. And for this, I need some calculations. So I need to know the number of periods, which is 10, and the number of scenarios, which is 10 as well. And I've given this a range name periods and scenarios, which are the actual range names on here. So that's the periods, this is the scenarios, and so on. But then I need to know how many calculation rows I've got. So this is my calculation. In this case, I need to calculate these 4 rows. So this repeatable calculation, you could do it lots of different ways. I'm using the count A function to count the number of non-blank cells, I should say, between rows F20 and F23 of the concept sheet here, which is 4. But then I want to add 2 blank rows before I do the next calculation. So my calculation block, in effect, is going to be a repeatable block of 6. So I'm going to need a counter that goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. See the mod function? And in row 1, it's going to have the opening balance. In row 2, the additions. Row 3, the deductions. Row 4, the closing balance. And rows 5 and 6 will be blank, and then it will repeat. Great. So here it is down here. Now there's 2 sets of calculations. I've got one for here and one for here. So first of all, let's look at this first calculation for the opening balance, additions, deductions, closing balances text, and then the 2 blank. And we've got this wonderful little formula here. Now, it's not quite as bad as it looks. And trust me, when I look at the other one, it certainly isn't that bad. So I've used the let function I explained earlier, and I've got a name counter, which is actually going to be this thing here. Now, remember, mod of a set of numbers, -1, comma the divisor, +1 gives you 1, 2, 3 up to the block, and then it repeats 1, 2, 3 up to the block, and so on. And what it's doing is that the sequence is generating a list of numbers, and it's scenarios times block. Well, scenarios is 10 and the block is 6. So we actually need 60 rows of calculation. So it's going to go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, a total of 10 times. And that's all this is doing here. And we're calling that thing counter. And then so if that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 is greater than calcs, which is the number of calculation rows, then it needs to be blank, which is, if we go back to here, why that's there. But then we've got this thing, map counter lambda x offset blah blah blah, and that needs a bit more explanation. So when this cycles into the 1, 2, 3, 4 bit rather than the 1, 2, 3, 4, 5, 6 part, we want it to actually give an item. And what I've got here is a simple illustration. I've got a sequence 1, 2, 3, 4, 5 and the letters A, B, C, D, E. And this 1, 2, 3, 4, 5 has been generated by the sequence function. And I want to be able to spill down here the A, the B, the C, the D, and the E in one formula. So I can use offset, which is what I discussed before. And I'm going to say, right, I'll start in this list. And then I want it to go this many rows down. So that's a spill. So to be 1 for the first row, 2 for the second, and so on. And no columns across. So just like that. And unfortunately, when I do that, it gives me hash value. Sometimes it will coerce and just give one value, and sometimes it will give errors like this. This doesn't work, but there's a wonderful trick using map lambda as a great formula combination. Think of it like the index match for lookup. And what you do instead is you say, okay, I need to add to this. So rather than do this, what I'm actually going to do instead is revise this formula and use the map function, the transformation. So I'm going to go map. And I'm going to say in here, okay, my counter is going to be this sequence here, C5, and I could name that if I wanted. And then I use a lambda. So I'm going to use a lambda, and I'll say, right, so the X here says, I want you to put this into the offset function, starting in this cell, and go X rows down. So this is your dummy variable, no columns across, close brackets. So and then another close brackets just to finish it off. So this here is what didn't work before, but the lambda will sort of force it through on each one, and it will then repeat for 1, 2, 3, 4, 5. If you see this work, voila, we get the A, B, C, D, E. And you need to do that in order to get your dynamic spill of whatever it is you're referencing. So if you aren't just doing looking at a particular cell, so we're looking at the text for opening balance, additions, and so on, you might need to do one cell multiplied by another cell divided by another cell. So for each cell you need to pick up, you'll have to use the map lambda. So it'll be map lambda for one range multiplied by map lambda of another range divided by map lambda of the third one. But that's how it works. So if we see that, we can actually return to our calculation here and see that the counter, map counter, is that sequence of scenarios times block minus 1. So it's 1, 2, 3, 4, 5, 6, 10 times repeated. Then we've got our dummy variable x. We're going to labels. So where's labels? Well, the labels is a range name here, which is this cell here. It's a blank cell, and it's going down 1, down 2, down 3, down 4. And then it won't do anything for 5 and 6 because of the blank. And so what's actually happening is it's repeating opening balance, additions, deductions, closing balance, then 2 blanks, and continuing. You see, if I change this to one gap, it will move it around. See? Easy. So getting the labels straightforward. More of an issue is this. This is what the range is for the rest of the calculation. And if we make this a little bit longer, you will see, oh, that looks pretty horrible, Liam, but it's not quite as bad as you might think. Looks awful, doesn't it? But actually, the first 7 rows of this lovely formula are simply defining variables and using the same naming convention as I've shown you previously, with lowercase range names having been defined by let and will therefore only be recognized by let, and those starting with a capital letter are traditional range names, i.e. they'll be recognized in other Excel formulae, they're range names in the actual file. So let items, so we're going to define something called items as scenarios. So let's just go down here. Let's actually just make this a bit smaller and just concentrate here on these. So items is scenarios, so that's 10. So that is how many scenarios there are. Calc rows is calcs, which is going to be the number of calculation rows. Group rows is the depth of the block. And periods is the sequence I26. So if we go down here, I26 is here. It's actually this thing here. So it's taking the numbers 1 to 10. So that's what's going on here. So we're taking the numbers 1 to 10. Then row ID equals the sequence of items times group rows, which generates a column vector of the integer values 1 through 60. So that's what's going on here. And group ID is then taking the integer value of those numbers 1 to 60 and dividing it by group rows, which is the depth of the block, 6, and adding 1. So the first one is going to be 1 divided by 6, which is 0 when you take the integer value of it, plus 1 is 1. The second one is going to be 2 divided by 6, which is 1 over 3, or 0 as the integer part, plus 1 is 1. So it'll go 1, 1, 1, 1, 1, 1 for the first 6, then 2, 2, 2, 2, 2 for the second 6, 3, 3, 3, etc., till it gets to 10, 10, 10, 10, 10, 10 for the last 6. That's what's going on there. So we have this sequence going on. And then calc ID is simply mod of row ID minus 1, comma group rows plus 1, which is therefore taking row ID, which is the sequence of items times group rows, which is generating a column vector of the integer values of 1 through 60, and using the divisor of group rows, which is defined as the block. So it's taking 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6. So we're just generating some sequences. So that's all we're doing in the first 7 rows. Now, after that, if we scroll down this formula, we've got 2 calculations where we're using an Hstack. So we're adding things in column-wise, as they say, and it's for this first column, the opening balance, because this is different from the rest. We want if it's the closing balance, so if it's the 4th row of each sequence of 6, so when it goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, when it equals the final row, the 4, we want it to put the closing balance in. So calc ID, is going to be that counter 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 going down, equals calc rows, which is how many rows in the actual non-zero calculation block is 4. So whenever that 1, 2, 3, 4, 5, 6 is 4, we're going to use that map lambda trick again. And this time we're going to be offsetting the group ID. So group ID is this integer thing of going through in here. We're going to say, okay, group ID is going to go 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, etc. To then take that, so when it's a 4 the first time, this value will be 1. When it's a 4 the second time, this value will be 2, and so on. So it will displace on the actual OB base. It'll take the first one down on the first appearance of 4. It'll go the second one down on the second appearance of 4, and so on. So we need to know what OB base is. Well, OB base, if we go back in here, this is the opening balance. This is the OB base cell. So when it hits the first 4, it'll pick that number. When it hits the second 4, it'll pick that number, and so on. And that's what's going on. So in here, in the repeatable calculations, first it comes to the 4, 4, 8, 9, second, and so forth. Great. So that's what's happening. And then we're going to stack that. And then what we're going to do to that is we're going to use a drop reduce to combine all the rest of it. So that only produces the first column. So what drop is going to do is get rid of an array, and reduce is going to sort of create an array here. So let's talk more about that now. I'm expanding the whole formula again now, because let's have a look what's going on. Drop here in this particular calculation has that, and at the end it does a comma, comma, 1 at the end is what's going on. So there's all this other stuff in here, but essentially it's drop long calculation, comma, comma, 1. So this assumes a long calculation produces an array, and it will remove the first column of the array produced. That's actually not too hard to follow. So therefore it begs the question, well, what's the array produce, which is the rest of this stuff starting with reduce. So we've got reduce, and then we've got the speech marks, comma, periods, comma, lambda, col period, Hstack, col, etc., and again more stuff. Right, let's ignore all the stuff underneath that and look at reduce in this part. So reduce will reduce the rest of the calculations to an accumulated value, which here will in effect be an array of 60 rows by 11 columns, not 10, when you actually think of all the calculations that are taken into consideration. And this is because there'll be an initial value, which is the blank. Hence, we need to remove the first starter column with the drop function. That's why we take it away. We don't need that initial value. Now, reduce uses the starter value of open close speech markers, which will no doubt cause errors for the later formulae, but it doesn't matter as it's going to be removed. And it should be noted that we cannot leave this starter value argument empty, even though it is optional. And this is because Hstack won't work with empty ranges or arrays and will return a hash value error instead. Now this formula then continues for periods, which here is 10 more times, where a lambda will define the starter value of the empty range or accumulator, that is col, and then consider each period separately. So read this formula carefully. The value of periods is the array of integer values 1 through 10, whereas period considers each value separately in the following calculations. No typographical error here. The more calculations we've got to do is going to return a column vector each time, one column by 60 rows, and Hstack will simply combine them. It is all of the above in this main formula section that you will replicate for other blocks of repeatable calculations. So all of this, everything to here, is what you're going to use every time you want a repeatable calculation. And now what remains is what's specific to the calculation block. And that's what we've got to go through. So that, to be honest, whilst this might seem horrendous, you're just really going to copy this, and it's this bit down here that is going to be tweaked each time. So let's talk about this now. And again, let is in here with some definitions. Opbal is using another map lambda. And so it's simply going through the group ID, which is the 111112222222333, etc. Going through, and then uses the offset function, offset ob underscore base, group ID period -1, if we actually look through that, to return the correct value. Now, due to how the controller count is defined, this is simply the values in the input table for the given scenario. We have to use period -1 as the number of columns to move to the right, rather than period, as drop will remove the first column. Because we need to move no columns for the first period, 1, one column for the second period, 2, and so on. Now the second line in here, if we go through, is adds or additions, you could say. That works similarly, but has a different starting point using offset, and then we've got period 1. So what the heck is period 1? Well, I'll just go back in here, and we'll go to period 1, and this is, if we just collapse the formula, it's going to start in this cell and then move so many rows down using the map lambda trick that we keep doing. So let's go back to our calculation, make it nice and big again. So in this one for adds, it's just going to go through, it's a different starting point. Period 1 is simply the heading cell for the first period. Arguably we could have used OB base again and changed the column movement to period instead. Now we don't need to define the deductions and closing balance, as the deductions are simply the removal of the opening balance, and the closing balance is simply the aggregation of the other elements. So now all we've got to do is, if the calc ID, so that's the cycle of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, is greater than 4, then it's just going to be nothing, so we're going to have our blank rows. Otherwise, we'll choose, using the choose function, the calc ID. If the value is a 1, we'll put in the opening balance. If it's a 2, we'll put in the additions. If it's a 3, we'll negate the opening balance. And if it's a 4, we'll add up the above, which is opbal plus adds minus opbal, which I know could just be adds, but I'm just trying to show this. And that's the calculation over and done with. Now, when you do this, your formula are going to be different each time. You're going to put something else in here, but you'll be using the map lambda trick throughout. But all this is going to be the same thing over and over and over again. Repeatable calculations, hey? Quite a lot to get through, but hopefully it's made sense. And I'm sorry I've gone a bit fast, but I've only got 50 minutes or so to get through this. So there you have it. We have our repeatable block, our calculation, which, as I say, could be forecast revenue for different products, depreciation for different asset classes, debt repayments for different debt instruments, whatever it might be. I just used a simple control account because it didn't matter what these actual calculations were. And then you can actually propagate it like this with just 2 dynamic array formulae, which, okay, may not be the simplest, but you can copy and paste and steal it. Look, I hope this has been useful. I'm sorry it's been at 100 miles now, but I really wanted to get through this and I needed to explain the actual functions. Look, if you have any more queries, drop me an email at liam.bastic@someproduct.com or visit our website at www.someproduct.com. Otherwise, thanks very much for listening, and please, can you fill out the feedback form?